In this video, I'll show you how to run a performance benchmark using Bud AI Foundry. It offers a simplified way to benchmark models on your own infrastructure, so you can quickly understand what to expect before deploying them to production. Model publishers often share benchmark numbers, but those results are tied to the specific hardware and setup they used. In the real world, your infrastructure, configuration, and traffic patterns are different, so you can't assume you'll get the same performance. Bud AI Foundry's benchmark feature exists to solve that gap. It lets you benchmark models directly on your own infrastructure, so you know what performance to expect before you commit to deploying at scale. It also removes a lot of technical heavy lifting. Without a tool like this, benchmarking from scratch usually takes a day or two of hands-on work. With Bud AI Foundry, you can kick off the same evaluation in just a couple of minutes through a guided flow and get a structured report at the end. Now, let's see how it works. First, log into your Bud AI Foundry dashboard and go to the Models section. From here, go to Benchmark History. This page shows all your past benchmark runs in one place. Now let's create a new benchmark run. First, enter a benchmark name. You can also add tags and a description so your team can easily search and understand what this run is for later. Next, set the number of concurrent requests you want to use in this benchmark run. You can run a benchmark using either a dataset or a specific configuration. If you choose configuration, you set a fixed number of input tokens and output tokens for every request. This is ideal when you want a clean one-to-one comparison, like comparing performance across different hardware configurations or comparing two models under the exact same token settings. If you choose dataset, the benchmark runs on an existing dataset where prompts and responses vary in length. This mirrors a more real-world scenario where input and output token sizes are not fixed. Here you can see a list of datasets available for benchmarking your models. Let's choose one. In the next step, you can select the hardware cluster where this benchmark should run. One thing to note is that in real-world applications, it's not just one model deployed on a cluster. There can be multiple models running in parallel. Here, you can select the shared hardware option to run the benchmark on a shared hardware cluster. Next, you'll see the nodes available in the hardware cluster that match your selection so far. You can choose a node and click Next to select the model you want to benchmark. Once the model is selected, you can review configuration options such as device type and the settings for tensor parallelism and pipeline parallelism. These parallelism strategies are automatically selected based on the best option for the hardware, model, and deployment choices you've already made. You can also choose the number of replicas you want to create for the deployment. Replicas describe how many parallel worker instances serve requests. You can also choose how many prompts to run. Even when using a dataset, you don't need to run the full dataset. You can limit the run to a specific number of prompts for quicker testing. For this demo, I'm choosing a small number. Once you've reviewed the configuration options, click Run to start the benchmark. The time to complete the benchmark depends on the model, hardware, and deployment settings. Once the benchmark is complete, you can review the results in the benchmark history page. At the top, you'll see a summary of the model used for this run and a summary of the cluster configuration it ran on. Here you can see the configuration used for the benchmark run. The section below provides a detailed breakdown of the results, including total tokens processed, time to first token, throughput per user, end-to-end latency, and inter-token latency, along with graphs to help you visualize and compare these key metrics. The table below shows detailed request level metrics as well. The purpose of this report is to help you answer a practical question. What performance should I expect from this model on my infrastructure under my expected traffic patterns? And that's it. You're now ready to benchmark models confidently and make infrastructure decisions based on real data.